His hair looks like Triple H. His hair looks like some Triple H type stuff right there.
And
Yeah, but it doesn't have the body.
Okay.
His hair looks like Triple H. Stone Cold.
Alright, the next couple of sections, we're going to take a look at special types of parallelograms. The first one today is a rectangle. So a rectangle has all of the
Guys,
properties.
there's like way too much. I'm sorry, Mr. Fach. I just can't focus on what you're saying.
So a rectangle has all of the properties that we've already talked about for a parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles add to 180, and the diagonals bisect each other. But then for a rectangle, we have two additional properties. Okay? The first additional property is that all four angles are 90 degrees. Okay? All four angles are right angles. And the second new property is that the diagonals are congruent. Right? So we're going to use these properties to set up and solve some problems today. But first, the other sheet that I gave you, we're going to use for the rest of this chapter to organize all of these properties. Okay, so let's start by filling in some of this information on this sheet before we get to the problems on the other note sheet. So at the very top, this is just a generic quadrilateral. A four-sided shape. So everything, the way that this chart works, everything underneath of a certain something shares the properties above it. So every single one of these shapes on this chart is going to share the properties of a quadrilateral. So what do we know is true about any quadrilateral? Four sides. So every single one of these shapes on here has four sides. What else do we know is true about any quadrilateral? Four angles. All right, so we can say four sides, four angles. There is something else, even more specific, I could say about the angles. They add a 360. Angles add to 360 degrees. Okay, so that's true of any quadrilateral. Right? So then, underneath of that, we have a parallelogram. Okay, we've been focusing on the properties of a parallelogram here. So let's come down here. I'm going to zoom in a little bit, actually. So on the parallelogram, what are the properties of all parallelograms that we've been talking about? Two sets of parallel sides. I'm going to say specifically opposite sides are parallel. And I'm going to use the notation for parallel. Right? These two lines like that. Okay, if you want to write out the word parallel, that's fine. Okay, but I'm just going to use the notation, which is these two parallel lines, essentially. Opposite sides are parallel. What else? What else is true of all parallelograms? Opposite sides are equal. What's that? Angles too. We can say opposite angles are congruent. What else? There's two more we've talked about. You can squeeze them in.
The picture's not that big.
I got 3 babies and hair. My hair
So we said something about consecutive angles, or angles that are right next to each other. What do I know about consecutive angles? What's that?
Oh, now it's gonna run more.
Consecutive angles are supplementary, right? Which means they add to 180. And then the last one had to do with the diagonals. What do I know about the diagonals in a parallelogram? They're not necessarily equal to each other. What do the diagonals in any parallelogram do? So the diagonals bisect each other. Okay, which means to cut each other in half. So these are the properties that are true of any parallelogram. So what we just mentioned then, the way this chart works, anything that's below that will share those properties. So over the next 2 sections, we're going to look at rectangles, squares, and a rhombus, or the plural of that is rhombi. So in this section, we're just looking at rectangles, right? So in a rectangle, we just mentioned our 2 additional properties. So in a rectangle, then, we have 4 right angles, and we have the diagonals are congruent. Okay, so we're going to keep this chart for the rest of this chapter. Okay? This chart's going to be very useful for us to organize all these properties, because this is a lot of properties that we're talking about for all these different shapes in this chapter. Okay, so this chart's going to be very helpful to keep all these straight. So don't lose this. Okay? So let's go ahead and start using some of these properties of a rectangle. Let's go back to the 6-4 note sheet here. Take a look at these 2 examples. All right, so for both of these examples, we are looking at the figure up above here, quadrilateral RUTS. And for both of these, it tells us this is a rectangle. So for example 1, it says that US, which is this entire diagonal, is 6x plus 3. And then it says RT, which is the entire other diagonal, is 7x minus 2. And we want to find x. Well, I know that the diagonals of a rectangle are congruent. So how would I set up and solve an equation here for x? Set the diagonals equal to each other. Right, so we'll say 6x plus 3 equals 7x minus 2. If the x is on one side, numbers onto the other side, We get that x is equal to 5. In the second example, we're given a couple angle measures. So in this one, I'm told the measure of angle STR. So angle STR is this angle right here, and that's 8x plus 3. And then I'm told angle UTR, which would be this angle, is 16x minus 9. So from that, I want to set up and solve an equation for x. What's the relationship between these two angles if I know this is a rectangle? If I know this is a rectangle, what's the relationship between these two angles here? Wait, not 180. Not supplementary. I don't know that they're congruent. They're going to add to 90. Okay? I know in a rectangle, this whole thing is a right angle. So these two angles will add to 90.
What's your fancy word for equal and 90?
Complementary.
That. See, look, now you might make me sound retarded. It's not fun.
So remember, complementary, 90 degrees.
It's weird.
It is. It's weird. It's dumb, but it helps you remember it.
Yeah.
So what we can do here is add these two angles together and set that equal to 90. So we can say 8x plus 3 plus 16x minus 9 equals 90. Combine my like terms over here, so that would be 24x, positive 3 and negative 9 would be negative 6 equals 90. Add the 6 over, 24x equals 96. Divide by 24. I think that gets x to be 4. Is that my final answer? You need to find the measure of angle STR. So STR was the 8x plus 3, so I'm going to take that answer of 4 for x and plug that in. So the measure of angle STR will be 8 times 4 plus 3. So 8 times 4 is 32, plus 3 is 35 degrees. All right, so our two big properties, in addition to all of our other things, there are two new properties for a rectangle. All 4 angles are 90 degrees, and the diagonals are congruent. All right. Questions? All right, then let's take a couple of minutes here and try a few of these problems down below. All right, so make sure that you understand each of these is a completely separate problem. We're not going to use our answer for number 1 to do number 2 or anything like that. These are all completely separate problems, just using the same diagram. All right? So let's take 10 minutes or so and try a few of these.
Yesterday on the way back to Grandma's on the highway. My mom.
Welcome back here, fellas.
All right, take a look up here at the answers. Okay, your paper doesn't include 7 and 8. Just 1 through 6 here.
Wait till we get home.
Excuse me.
I heard you.
5?
I
Sure.
heard you.
So, let's look at number 5. We know that the measure of angle AED is 12x. And I know the measure of angle BEC is 10x plus 20. So these two angles end up being vertical angles. We know vertical angles are equal to each other. So I can say
You want to sniff?
10x plus 20 equals 12x. Then I want to get the numbers on one side, the variables on the other. I already have numbers isolated, so I can just bring the variables to the other side. We get 20 equals 2x. Divide by 2, and we get that x is equal to 10. But then the question says, find the measure of angle AED. So I would just need to plug that back into my expression for angle AED. So that's 12 times my x of 10, which gets me 120. Other ones that we want to take a look at? Number 4. I think 4 was probably the trickiest one.
Yeah, definitely.
So on this one, we are given that angle BEA is 62 degrees. And then from that, we want to find the measure of BAC, so this angle down here. Well, since this is a parallelogram and a rectangle, I know the diagonals bisect each other and are congruent. So what that means is both of these pieces, BE and AE, would be congruent. So what we end up with here is an isosceles triangle, right? What that means is if these two sides are the same, these two angles would be the same. So I could call both of these x, since I know they're the same, and now since this is a triangle, I know these three angles will add to 180. So I can set this up as x plus 62 equals 180. Yep. So subtract the 62 over. We get 2x equals 118. Divide by 2. And we get that each of these angles then is 59 degrees. So that's one nice thing about rectangles. All 4 of these little triangles that are created end up being isosceles triangles. So something like this would always work if we have a rectangle. Okay? We know that all 4 of these little triangles will be isosceles triangles. Any other questions on the front here? All right, let's flip over to the back then.
He points at you. You can be pointing at the flag and pointing at you right now. Listen, if we start answering the completely different.
Dude, do the.
I can't do it. I can pop my jaw and then.
But if you spend to it.
Right.
Like,
Oh, dude.
Alright, on the back,
voted.
we want to take a look at ways to prove that we have a rectangle in the coordinate plane. So, we already talked about proving that something is a parallelogram, right? We used slope to say if opposite sides have the same slope, then it's a parallelogram, and we used distance to say if opposite sides have the same length, then it's a parallelogram, right? We're going to do something very similar to prove that something is a rectangle, right? I want to, again, find the slope of all 4 sides. So, we know that our slope formula is y2 minus y1 over x2 minus x1. So if I want to find the slope of AB, I'm labeling x1, y1, x2, y2, plugging all of that information in. y2 minus y1 will be 3 minus 0 over -2 minus -3. So that'll be 3 over -2 plus 3 is 1. My slope of AB is 3 over 1. I want to find the slope of my other 3 sides then. So, slope of AD, again, y2 minus y1. So, label AD x1, y1. So, oops. Label AD D is x2, y2. So I already labeled A as x1, y1. So y2 minus y1 would be -2 minus 0 over x2 minus x1. So 3 minus -3. So -2 minus 0 is -2 over 3 minus -3. That'd be 6. And then we want to reduce as far as we can. So -2 over +6 would reduce to -1/3. And we want to do that for our other 2 slopes as well. Right? We're running a little bit short on time here. So I'm going to just tell you that the slope of CD is going to be 3 over 1. And the slope of BC, we will get -1/3. Okay? So for a parallelogram, we said opposite sides have the same slope. And that's true here. Opposite sides have the same slope, 3 over 1 and -1/3. But for it to be a rectangle, we have to have one additional thing. Okay? We have to have consecutive sides be perpendicular. What's the relationship between perpendicular slopes? Opposite reciprocals. Okay, perpendicular means slopes are opposite reciprocals. So if we look at these sides, we've got +3 over 1 and -1 over 3. Those are opposite reciprocals of each other. Okay, so the fact that opposite sides have the same slope makes it a parallelogram. Then the fact that consecutive sides have opposite reciprocal slopes makes it a rectangle. Okay? Questions on something like that? Right? The second method then is to use the distance formula. If you remember, we said if opposite sides are congruent, that makes it a parallelogram. So remember the distance formula, x2 minus x1 squared plus y2 minus y1 squared. So to use the distance formula, we actually have to find 6 pieces of information. Okay? So if you have the choice, using the slope formula to prove that something is a rectangle is going to be less work, probably a little bit easier. But if you don't have a choice, right, sometimes I'll just tell you, use the slope to justify or use distance to justify. So what we would need to do is find the length of all 4 sides using the distance formula, just like we did. So again, we're running a little bit short on time. So what we would find out here if we plugged all of this information into the distance formula is that AB would be the square root of 10. CD would be the square root of 10. BC would be the square root of 40. And AD would be the square root of 40. So we can show that, guys, we have 5 minutes left. I'm not sure why we're packing up. We can see that opposite sides are congruent. That just proves that it's a parallelogram. To go one step further then, to show that this is a rectangle, we need to look at the lengths of the diagonals. Right? defining property with the diagonals in a rectangle is that the diagonals are congruent. So, if I can show that AC and BD then have the same length, that makes it a rectangle. So, if I look at this diagram and I find the length of AC, let's see, that's 5, 6, 7, 1, that would be the square root of 50, and then BD would also be the square root of 50. Okay, so that ends up proving that this figure is a rectangle. Okay, there, I am going to ask you to try one of each of these for part of the homework. Okay, so you need to find slope of all four sides and show that opposite sides have the same slope and consecutive sides have opposite reciprocal slopes. If you're using slope for length, you need to show that opposite sides have the same length and also that the diagonals have the same length. Okay, so for the two problems in the homework, you should have a little bit of work. Right? Just saying yes or no is not an actual answer. You need to show yes, it is a parallelogram with all of this work, or no, it's not with all that work. Okay?